to Jeff.
Okay, now let's find out how people finally started making money with these products. Well, the EEPROMs were making money all along for Intel. They were making money pretty well, and that's sort of what caused a number of the next other events here, all that money that was being made on EEPROMs. Underneath the radar, they were working on E-Square as well, and ultimately were able to introduce the world's first commercially successful EEPROM in some significant volumes. They were sold mostly to military at first because it was pretty expensive, but ultimately with smaller capacities and different interfaces, they ended up widely dispersed in many applications. So George Perlegos had started at Intel earlier than the E-Square activity and worked first on some early EEPROMs. George is with us tonight as well. Maybe in the Q&A we can get him to give some more detail.
Could you raise your hand, George? Where are you sitting? Right over here. Glad to have you here.
Yeah. So after the Frohman EEPROM was doing so very well, it was made of PMOS and it took 3 high voltages. He was able to make the first NMOS version that worked with an 8080, and later the first 5-volt only version that worked with an 8085. Both of those still required off-chip programming, off-system programming as EEPROMs. Then in late 70s, he too created his first E-Square, and that's the one that became commercially successful. About that time, in the late 70s, there was another movement going on in Intel. They had an unsuccessful CCD business. And the team there, knowing it was unsuccessful, decided to branch out into other things, and they thought they would try to make thick oxide E-squares. But the company didn't want to do that. So a team from that CCD group left and formed the company Xicor, led by Rafi Klein. Coincidentally, one of his co-founders and a board member was Julius Blank, one of the original Fairchild founders of the traitorous 8 who left Shockley. Anyway, this Xicor built a business out of their thicker oxide E-squares. That goes on. Let's turn to the next page here.
I love that. That's ex-Intel Corp company was the name of that. The company was based on that.
Well, moving along a little bit in time, in the early 80s, Intel was expanding and they decided to move all of their non-volatile memory activities to Folsom, California, outside of Sacramento. And as a result, a number of the folks who didn't want to move left the company and decided to continue pursuing E-squared, and they formed SEEQ, S-E-E-Q, where E-square is our middle name. They were able to solve one of the major problems with E-square, which was that you needed lots of voltages to program it. They were able to build an on-chip charge pump to create the high voltage necessary for programming and erasing. With Fowler-Nordheim tunneling, you don't need much current, but you do need high voltage. And so a low current charge pump was easily installed, and SEEQ made a pretty good business out of that and eventually expanded into other non-memory applications. About a couple years later, in '84, 2 of the founders of SEEQ, which were Gordon Campbell and George Perlegos, left to form Chips and Technology, which was only logic products. George liked memories better, apparently. We can ask him more detail later why he left Chips and Technology the same year and started Atmel to continue making, originally making non-volatile memories. And that company was started at the end of '84. And the company brought out its first E-squared made in CMOS, which was essentially what Hughes had tried to do earlier, but Atmel, I think, was one of the first ones to do it commercially. Intel's E-squared had been NMOS. In the late 80s, using basically their E-squared technology, they also brought out an early version of their NOR flash. Later, they switched away from that E-squared technology to pure flash technology, which you'll hear about from Stefan here in a little while. But at first, they brought it out with E-square. And that business, both of Atmel's non-volatile businesses, EEPROM, Xicor, and Flash, all three of them did fairly well over time. And ultimately, they integrated that technology, especially the NOR Flash, into microcontrollers. And we're one of the first companies to do integrated, reprogrammable, non-volatile microcontrollers. With that, I guess the last thing to say there is that in the mid-90s, Intel was able to acquire SEEK's original E-square business.
Or Atmel.
Not Intel. And ultimately now we've just heard in the past week or two that Atmel is likely to be acquired by one of their former co-companies from the TEMIC organization in Europe called Dialog Semiconductor. Anyway, maybe we'll hear more about that in the Q&A, but let's move on to more non-volatile memory. Oh, still my turn. Now we're back on to Fujio Masuoka. He too, as a young engineer, I told you had worked at Toshiba getting products not built. He became sort of a rebel within Toshiba. A little bit later in his career than his first start, he was able to give an ISSCC paper shortly after he had heard or read of Doug Froman's one in 1971. In 73, he had developed and was able to present a much faster programming EEPROM, which used a double gate instead of a single gate. The net result of that was Toshiba yet again failed to produce it. He also worked on some DRAMs through the 70s and into the 80s. And that brings us to the next interesting phase. Well, he had worked, there's the NOR paper, NOR Flash. Let's move to the next slide. As a DRAM engineer, he was called to testify when TI, worried about Japanese dumping, had decided to do a DRAM patent infringement suit against Toshiba.
And many other companies.
And many other companies. And Masuoka was called to Washington to testify at the ITC, who arbitrates the international patent disputes. It was a long trial, 3 or 4 months, and he was bored for most of it. So in his oral history, he claims in his boredom time, he thought up the idea of NAND flash. And thought, and so he thought so well that it would work, he actually wrote up 5 patents while sitting around the ITC. When he got back to Toshiba, he explained what he had, and yet again, they failed to capitalize on it. But the patents were filed then, and the papers were published, so there was that precedent in the industry.